Hello everyone, today we are going to study about gas, a basic idea about the gases. The property of gas are, it's a state of matter with weak interparticle attraction, large interparticle space, high kinetic energy, and all gases exhibit uniform behavior under similar conditions of temperature and pressure irrespective of their chemical nature or color or odor. Now the behavior and characteristic properties of gases are composed of molecules, which we have studied from very smaller classes. These molecules or the particles are in constant random motion, and this kinetic theory helps us to explain the relationship that exhibit between pressure, volume and temperature of the gas, which will be much more clear when we study about the Boyle's law and the Charles law. The kinetic molecular theory explains the behavior and characteristic properties of gases. The first is the composition of gas. Gases are made up of molecules which moves in all possible direction at all possible speed. The molecules are negligible in size as compared to the volume occupied by it. So we all know that the gas is made up of molecules and they keep on continuously moving in all possible direction at all possible speed, and these molecules are very small as compared to the volume that the gas occupy. The next thing is that the gas do not have any definite volume or shape. Due to the negligible force of attraction, the molecules of gases are free to move around, acquires the entire space available and attains the space of the container. The third property is that the gases exert pressure in all directions. Why is it so? Because they collide with each other and also with the walls of the container. Due to this collision, the gas molecules exert pressure. So the collision happens between each other and also the walls of the container, and due to these collisions the gas molecule exert pressure. So the gases are highly compressible, which we all know. It is due to the large intermolecular spaces between the gas molecules. The gases are highly compressible. They decrease in the volume as molecules come closer on exerting force on it. They are highly expansible. The gases are highly expansible because due to the intermolecular spaces present in them. Whenever we decrease the pressure, the intermolecular force of attraction reduces and the intermolecular space increases. And when we increase in temperature, then also the gas become highly expandable. Why? Because there is an increase in the kinetic energy of the gas molecule. So whenever there is an increase in the kinetic energy of the gas molecules, it causes expansion of the gases. Gases have low density. Why the gases have low density? Because the number of molecules per unit volume in a gas is very small as compared to the solids and liquids, all because of the large intermolecular spaces of attraction. All because due to the large intermolecular spaces present between the gas. So these are the properties that is been explained very nicely by kinetic molecular theory. The last two property is that gases show diffusion. Now, what is diffusion? Diffusion is the process of gradual mixing of two substances kept in contact by molecular motion, and this one we will come to know in detail in the video that is being taken from YouTube at the end of this slide. Gases can be liquefied. So gases can be liquefied on cooling. It can be liquefied on cooling because the kinetic energy reduces, and on high pressure because the intermolecular space reduces. So this is very important. You can liquefy the gas only when there is a cooling and high pressure both together. Then only you can liquefy the gas very easily. Otherwise it becomes very hard. It becomes a tough job. Why? Because you have to reduce the kinetic energy of the molecules as well as the intermolecular spaces. Then only a gas can be liquefied. Now let us see a small video that will explain the diffusion of the gases very nicely.
Water vapour spreads out into the atmosphere. It's carried by the wind, but it can also spread out of its own accord by a process known as diffusion. Invisible gases behave in the same way. The particles in a gas move randomly in all directions. This helps explain why a gas diffuses from one place to another. You can see diffusion happening on a small scale in the lab using bromine, an orange-coloured gas. Place a jar of air on top of the bromine and it slowly starts to spread. It's moving up the tube against gravity. Over time, the two gases mix. After half an hour, both containers have a uniform colour. It takes time because the air and the bromine molecules are colliding with themselves and each other. So what would happen if there was no air for the bromine to bump into? All the air has been removed from this apparatus, apart from the flask containing bromine, which is isolated by a tap. Open the tap and it spreads immediately. Watch again. In a vacuum, there's no air to collide with. The bromine diffuses much faster. See how slow the diffusion is when the flask is now full of air. It takes several minutes to get just this far. This simple setup can be used to compare the rate at which different gases diffuse into air. Nitrogen dioxide gas on the left is similar in colour to bromine on the right, but bromine molecules are much heavier. The lighter nitrogen dioxide diffuses more quickly. We can also compare the diffusion rates of other gases. Ammonia and hydrogen chloride gas are colourless, but when they meet, a white cloud of ammonium chloride forms. A piece of cotton wool soaked in concentrated ammonia solution provides ammonia gas. Concentrated hydrochloric acid provides hydrogen chloride gas. Place the two pieces of cotton wool at opposite ends of a tube and the gases spread out. You can compare the speed at which they approach each other by looking out for a cloud of ammonium chloride. After less than a minute, a white ring begins to form, marking where the gases meet. The white solid is closer to the hydrogen chloride end of the tube, on the right. So which gas has travelled faster? Another way of monitoring the progress of the gases is to run a piece of damp indicator paper along the tube. Hydrogen chloride gas turns it red, ammonia turns it blue. Why does ammonia travel faster?
Thank you everyone for watching. Have a nice day. Please like and subscribe my channel. Thank you everyone.